Okay, so this is the last week of our 6 weeks. I am not taking any more grades for this 6 weeks. So things that we have done towards the end of last week and then through this week, they are going on next 6 weeks. Okay, so everything that's in there is in there. And like I said, at the end, I'm going to give you a few minutes to where you can go in and look, figure out about taking retests, etc., and finishing some incomplete projects. Some of y'all are forgetting that when I am out for a sub and you have an assignment, it is expected to be done in class with that sub. You're not getting retakes on that, because that's just you being lazy and trying to get away with not doing anything when there is a sub here, and that is not acceptable. But I will give you a chance to fix some projects with some bad code or incomplete. So what we're looking at today are Sprite Walls. This will let us treat sprites as areas that cannot be entered. So we've looked at the colliding rectangle, the is colliding rectangle. Well, this is going to act a little bit different. So Sprite Walls, we can treat one sprite as an impassable barrier for another sprite. So that means when it gets to it, it can't go through it. It's got to go around it somehow. So we'll use this for any program where one sprite has to be able to treat another sprite like a wall. Example, not being able to move past it. Some examples might be a floor or platforms in a platforming game, walls in a maze. Those can also be them. And a sprite that catches another moving sprite. Are you still having trouble? Okay, so what do we mean by a sprite wall? If you look up here at this example, when a sprite is moving, we want it to stop completely when it hits the wall, but then still be able to move as long as it is going away from the wall. This is trickier than it sounds because we actually need to stop the sprite before it intersects with the wall, so it doesn't end up partially stuck inside of it, okay? So as it's moving towards the wall, the top one here at the right is showing how it actually gets inside the wall, and we don't want that. But the one at the bottom gets close to the wall and would be able to stop. All right, so how can we use collision to stop a sprite when it hits a wall sprite? So this is the code we have for is colliding rectangle, and it's asking if sprite 1 is colliding with sprite 2. So what we need to be able to do is check when the sprite is about to collide with a wall or just starting to collide, and then stop it from doing so. Is it going to be as simple as just checking if a sprite is colliding and setting speed to 0? If we test if something is colliding and then set speeds to 0, that means that the sprite will still be colliding with the wall, which means that it will never be able to move again. We need a way of stopping it while it is still outside the sprite wall. So let's go ahead and move to the code real quick. And there are actually a number of different ways to do this, but we're going to look at one that's the most consistent and widely applicable. We start by writing code that will check every frame to see if the sprite is in a safe position, where it is not colliding with the wall, and save that position. So what we want to look at in our code we have an area here called good positions. So what we're going to do is we are going to check to see if not club is colliding rect with card, then club last X equals club center X, and club last Y equals club center Y. So it's starting by saying if not, okay. So what we're doing with this code, we're checking to see if the sprite accidentally moved into the wall on this frame. And if it does, we set it back to its last known safe location. Then let's go ahead and scroll down to collision checks. Collision checks, we're going to put some similar code. Excuse me. So you could actually copy the other code, and all we are doing is changing the if not club is colliding with card, we change it to if club is colliding with card. And then you are going to flip-flop, because you'll notice that the results of this condition, the first one was club last X equals club center X. Well, now it's club center X equals club last X. So you're going to flip-flop those as well. And when you finish, go ahead and run your program so you can check it. Okay, and you're using your up and down arrows, left and right arrows to see if you can't move the club over the card. And it doesn't seem to be working. So what we're doing here is we are effectively checking every frame to see whether the collision occurred. And if so, undoing the movement that was just done. This should work for all different kinds of movements. So now we're going to go ahead and try it with the heart. So we can go up to this good positions area, again, the comment, and we can copy our code. And we can paste it and change where it says club to heart on each line. And then we'll do the same thing under the collision area. You'll copy that code, the collision check, and you will paste and change the everywhere it says club to heart. Once you get those codes in, run your program. So the club moves with the arrows, the heart moves with your mouse. Now, what I do want you to check, if you just kind of bump your mouse up or your mouse up to the card, the heart stops sometimes a little bit further away than other times. Okay? But if you move it super fast, what does it do? Yeah, it goes, I don't know, over it, under it, through it, something, which is not really what we want. So sometimes you can get the heart to stop a big distance away from the card. This happens because the last safe spot was the previous frame. So the distance away from the card that the heart stops is based on how far we can move the mouse cursor in one frame, going from a safe spot to a colliding spot. Okay, does everybody have their code in and has been able to check it? Okay. All right, so here we have the two pieces of code, or I shouldn't say code, but the description. If sprites are not colliding, then save safe position. If sprites are colliding, return to the safe position. That's what that code is doing. Okay? So when using Sprite Walls, we first check to see if the sprite is in a safe, non-colliding spot, and if so, save that location. Then later we can check to see if the sprite is colliding with the wall, and if so, move it back to its last known safe location. So how could we use this syntax with some of our earlier examples? We could check for whether a game character is standing on the floor or a platform to make sure they don't keep falling through it. We can check whether the character is in the empty part of a maze or within the walls, and always set them back into an empty space. Okay? So please hit submit. Some of you guys are forgetting to submit parts of your work. And I am going to open up Sprite Walls 1, and we're going to work through 1 together. And then you'll get to do 2 on your own. Whoops. Huh? All right, so for Sprite Walls, what we're doing is, again, you have that definition, treating one sprite as an impassable barrier for another sprite. There's the example. What we have to do is use those 2 parts of the code so that we can get that safe position saved and be able to return it to that safe position. So you are going to open that code if you have not already. The solution shows somebody, I don't know who, and every time I can move them up with my mouse a little bit, and then as they fall, they fall to the bottom of the scene, of the stage. Where it stands right now, it still falls to the bottom of the stage. Hang on. All right. Oh, this is Socrates. Okay. So what we have to do is we have to prevent the Socrates sprite and the tower sprite from colliding so that he can't move through the solid stone. When Socrates is saved by dropping him on top of the tower, he should stand in one place without falling. So to save Socrates, click and drag him above the tower to place him on top and out of the water. All right, so we're using the is colliding rectangle, center X, and center Y. We have our setup done for us. We have our main loop started. We are getting the mouse position, saving it to X and Y. We have speed set. We need to look at not colliding. So find that section of your code. All right, so do you remember how we start this if statement? In the colliding part. If not, correct. So we're going to say if not, Socrates is, and make sure you spell Socrates correctly. If not, Socrates is colliding rect with the tower in parentheses. Then we are looking at Socrates last X. And it's going to equal Socrates dot center X. And then we'll do the same thing for Y. So I'm copying and pasting so that I am working more efficiently. Okay, and then we need to go and check. We have that was the not colliding. Now we have to go down to colliding. This time we are doing an if statement, and we still want to know, is Socrates colliding with a rectangle, tower, and this time we reverse those two pieces. So now we're saying Socrates dot center x equals Socrates last x. And then I'm going to copy that and paste it and change the x to y. And then give it a run. And remember, you're having to use your mouse, and it's with little clicks. He doesn't, excuse me, doesn't go in one fell swoop. And so check and see if he'll go to the top. Spell your last name. OBI? Yeah. Okay. Thank you. Okay, did everybody get it to work? Okay, so I'm going to open up the other one, Sprite Walls 2. I'm also opening up Lesson Check. Guys, you need to make sure that you are hitting submit on both of them. It does not save your lesson check if you don't hit submit. Go ahead and work on those. You can refer back to your code to help you out. And then when you are done, you should be spending that time checking Skyward to see what you are missing, what needs to be fixed, and so we can plan for a test retake.